Okay, now we'll start with the lab session on probability distribution. So you will see shortly we will be using pandas data frames and the scipy.stats package. Of course, we also need to do some calculations that will involve using NumPy. And then to generate plots, we'll need matplotlib.pyplot. So we import these packages, and I've provided this demo data on GitHub. It's on the GitHub page right here under topic 6, and it needs to be in the same folder where this Jupyter notebook is located. And we'll be opening it up in Python and doing some calculations with it. So this is the data. How do you read a CSV file? We use pandas.read_CSV. How do you spit out data from Python to CSV file? Use pd.to_CSV, right? We talked about those before. And then you can print the standard deviation of the data sitting in this CSV file. So if you run that, this is what you get. So we know we don't really need this. All we need is this number right here, right? So you can grab just this number by doing this. So whenever you see that it's returning a series instead of one single number, then you can convert that series to a floating point number by surrounding the value with float parentheses, right? So you do float, you open and close parentheses, and then you provide this np data frame dot standard deviation, which you already had before. So this will print out one number. It won't show this np stuff. So by default, you will get this, right? And this is what the data looks like. We get that by typing npdf as the very last command in a cell. And it starts, these are the first 5, these are the last 5. And we need to be able to do some descriptive statistics with this information, which we'll do shortly. To figure out why this data frame gives this kind of error, this kind of output, we can print this also, which gets the type of the npdf.standard, and that's, you see, it's pandas series, which is why it shows the name, the column header, and the data. So if you want to do calculations, you wouldn't be able to do that directly on this series. So important to surround that series with floats, and then it will return just this number, which is what we do here, and that gives us the number. Good. So we can run each of these commands, like comment out all the rest or copy just one and paste it in a new cell and run it and see what you get. Of course, this will show you the first 5 items. This gives some information about the data frame, and that information is precisely what's shown here. It tells you there is one column which has a column header np. The max will get you the maximum value in that data series, and it's going to come out in this form. And because we don't want this form, we will have to do float. If you want to get just the number and you don't want the series, you will have to do this, right? Which I explained earlier. Same deal with all the other functions: minimum, mean for average, median, mode. We talked about this previously. And now we have quantiles. So quantile, and within the quantile function, we provide a list of 3 values. It can be any number, and these are just the quantiles, which represent the percentile, basically. So this will give you the data at the 25th, 5th, and 75th. Sorry, the 25th, 50th, and the 75th percentiles. So it will give you the data at those percentile. So it basically will order this entire data frame, right? And then pick the values that are at these percentiles. So it will return 3 values. And that one is important because you haven't done that before. So I'll create a new cell and then run this by itself, and that's what you get. Data at the 25th, 50th, and 75th percentile. Very nice format. What if you wanted to see the 10th percentile, 50th percentile, and the 90th percentile, which I will ask for in the lab session, and this is how you'll get that. But it's important to realize these are percentiles, right? If I ask for P10, P90, and P50, then it's 1 minus these results. So basically you flip the 90th percentile with the 10th with P10, and the 10th percentile will be P90. P50 is the same as the 50th percentile because it's just in the middle. Standard deviation without the series stuff, surround it with float, and then you can use our F formatted print statement, right? And that prints out this standard deviation and the variance. And again, these are the quantiles I basically just added here, so I can cut it and take it out. Data frame.describe, already talked about this for descriptive statistics, right? Minimum, maximum, count, mean, and these quantiles. What if we want to find out the cumulative production, because NP is cumulative production, right? So this is the full data again, summarized. It's cumulative production, and then we already asked for for 10th, 50th, and 90th percentiles. So that basically went into the data and gave us the cumulative production at those percentiles. What if we want to find the percentile corresponding to a given cumulative production? So it's like the inverse lookup. So again, let me repeat. Right now, we're given the percentile. We're given the percentile, and then you will find the cumulative production. What if you are given the cumulative production and you are required to find the percentile? So you need to do something else, right? So it's not going to be quantile. It's going to be using the SciPy statistics package. You're finding the percentile of score that this cumulative production is within this column, right? So we're looking for the percentile that basically 11 million stock, 11.5 million stock tank barrel corresponds. And for this case, it shows you it's 89.6 percentile. And I'll continue from here in the next video.